Hey guys, welcome to the Level 1 Tables, Equations and Graphs paper from 2021. If you're joining us for the first time, the way this video works is that I go through each question and let you guys know what you need to do for achieve merit and excellence. The best way to watch this video is to pause the video at the start of each question, try the question out by yourself, and then unpause the video to have a look at how I go about with the answer. So without further ado, let's get started. Alright guys, so getting started with question 1 here. What we've got here is give the equation of this particular graph. Now I know that last time I've done these types of exam papers, people have asked me, oh, can you show us without graphics calculator method as well? So I am going to show both methods in this case, just so that we can kind of pick up both of these things, right? Alright, so what are we going to do? We're going to have to pick up a couple of points first. And I'm going to do this the long way first. So the long method is this one here. I'm going to have a look at this here, which is -3. That -3 right there is the y-intercept. So if you have like a straight line equation, we know that we can say that y equals to mx plus c. So the c value being wherever the line cuts the y-axis. So in this case, what we've got here is mx -3. Now we need to figure out what the gradient is, which is what m is. So gradient, which is also known as m, can be written as, I mean, you know, in your guys' classes you might have done it completely different. You might have done rise over run, you might have done change in y over change in x. It doesn't really matter. Pick the one that you feel confident in, and then you can actually go with it. Now the one I'm going to use is change in y over change in x. So I'm going to look for another point that's quite clear. And when I think about a clear point, I don't want to be picking like this point here, because it's kind of like in the middle of nowhere. But what I could do is I could actually pick this point right here, which happens to be 2, -10. And of course I've got my y-intercept, which is 0, -3. So change in y over change in x. And again, like I said, you don't need to do it this way. If you have a way and you're confident with it, go for it, all right? So in this way, all I've got here is a change in y. So I'm actually going to go gradient is equal to -10 minus -3 divided by 2 take away 0. So all I've done is change in y over change in x. Now if you're doing rise over run, you might actually do run as 2. And instead of rise, you're actually going down, and because you're going down, that's going to be -7. All right, so your gradient is -7 over 2. But if we have a look at what we've done here, we're going to get -10 plus 3 over 2, which also is what I've got with the rise over run as well, which is -7 over 2. So the equation is y is equal to -7 over 2x and -3. Now grades wise, this is actually worth and achieved. Now if you're using the graphics calculator for this, what you want to be doing is we're just going to go quickly into menu, we're going to go into stat mode, and we're going to put in those two values. So we're going to put in 0 and 2 because those are my x values, and then I've got my y values, which happens to be -3 and -10. So putting that in there, graph 1, calc, so that's F1 again, and we're looking for a single variable, which is x, and there we go, we're getting -3.5 and -3. So that a value there, that's the gradient, which is -3.5 or -7 over 2, and b is equal to -3. So if you're using the calculator, you might have actually just written your answer as y equals -3.5 x -3, and that's absolutely fine as well. Cool, so that is question 1a. Let's go to question 1b, and I've kind of kept it close here just so that we can actually put this together. Alright, so what we've got here is find the equation of the new line if the graph is translated 20 units up and 10 units to the left. So what we're looking for is it is going up by 20 and it's shifting to the left by 10. Now, with this question, guys, and I'm going to be honest with you, anytime you get a parabola or a exponential curve or a straight line, and you're doing some translations, it's actually not too bad, all right? Because all it is that we just got to replace some numbers here. Now, let me show you what I'm talking about here. So we've got 20 units going up, right? Now the up, so first I'm going to write this equation, which is negative 7 over 2x minus 3. All right, the first thing to have a look at is the plus 20, because it's actually moving up 20. So imagine it like this. You've got your straight line and you are adding 20, which means the whole straight line is going to move up by 20. So that means at the end of this equation, all I need to do is just add plus 20 in it, because that will actually shift the graph up by 20. The next thing is I need to move the graph to the left by 10. Now for this particular part, what you need to realize is that we're actually going to go and find out all the x values, or wherever there's a variable x, and we're going to shift it by 10. All right, and I shouldn't have put this as plus 10. I should have really put this as just, I shouldn't have put plus 20 there as well. Sorry about that. Let's just try that again. So that's your 20 right there, because it's moving up means plus. You know, I shouldn't have put that plus. And left is 10. So what I'm going to then do is, wherever there's an x, I need to replace it with x plus 10. So then this equation is going to be negative 7 over 2 x plus 10 minus 3 plus 20, which happens to be plus 17. And I'm looking at the answer schedule. You don't even need to do that. You could just leave your answer like this. And let me show you guys, where did it go? Yeah, here we go. So as you guys can see, you can actually leave your answer like this. But I'm just kind of reading through that. Correct simplified equation is going to get you a merit. So I guess you do need to simplify it here. So I'll show you guys how to do that quickly. Sorry, I kind of missed that. I thought it was just leave it like that, but there we go. They do say any equivalent, but it's all right. What we're going to do is we're just going to expand this. So we've got negative 7 x over 2. So all I'm doing is I'm expanding the brackets here. And then I've got negative 7 over 2 times plus 10, which is going to give me minus 35 minus 3 plus 20. And if I put that all together, I am going to get y is equal to negative 7 over 2x. What do we got? 2018 minus 18. So grades wise, if you have a look at this, if you cover the vertical shift is correct, you're going to get an achieved, or horizontal shift correct is achieved. And I guess if you simplify it, you are actually going to get a merit there for this question. So a merit is right here, and achieved is getting this, or actually wait, let's try it here. Getting achieved would be here, or getting those parts right there. Okay, so let's go to the next question there, guys. I'm going to give you guys a bit of time to just read through this question here, because yeah, there's a lot happening in this question. Now the issue with tables, equations, and graphs paper is that, you know, like there's just so many things happening in that paper, like trying to put it all on a screen is quite tricky. But I've tried my best here, so I do apologize if things get a little bit smaller, just because I have to zoom in and out of things. But anyway, look, let's start with this question here. We're looking at Anne first. She starts with 4,000 points. As she plays, she loses 500 points every minute. So we're going to fill up the table for that first, which means she's starting at 4,000, 3,500, 3,000. I'm going to pause here and I'm just going to fill up the table. Got about to 0, and then she loses no more money after that. All right, next we're going to look at remaining points for Ben. So Ben actually starts with 12,000 points, and he loses half his points every minute. So that means he's going to go to 6,000, 3,000, and once again I'm going to pause and just kind of continue this. Keep kind of going to 46.88 and 23.44. 2 decimal place should be all right. And finally, Charlie starts with 12,250 points. And he loses all the points as shown on the graph below. I'm guessing this is Charlie's points right here. So with Charlie's points at 7th minute, he's actually on 0. Yep, that sounds about right. And the rest of the points, you just have to kind of like read it off the graph. So we're gonna go here. Jeez, that is some nasty looking numbers there. 12,000 looks like it. I don't know, 11,000. I mean, you guys could just put some rough numbers here, because obviously it's quite hard to kind of see exactly where that point is, even if I zoom in, right? At 3, he's at 10,000, so that's okay. I just lost my paper. At 4, he is, what do we got, 8,250? At 5, looks like 6,000. And at 6, 3,250. And of course he loses everything after that. Okay, so with completing this table, table of values with at least 5 correct. Okay, this is one of these weird questions, right? Look at this. Look what we've got here. We've actually got a lot of things that are happening here for this particular question, this one question. So you could get an achieved if you get table of values for and Ben with at least 5 correct values in both. All right, so that's going to give you an achieved there. But then we've got a whole lot of extra things that's happening here for merit and excellence, and I'll kind of go through each one of them separately. So when we go to the part of the question, we've done part 1 of the question, which is completing the table below. Now part 2 is use the axis provided on the page opposite, draw the graphs representing the number. So with Anne, I'm going to be doing Anne in red color here. So she actually starts at 4,000, and after 8 minutes she is at 0. I'm sorry guys, this is the best I could do here, but I'm going to try. See if this works. Yeah, it's not bad. Okay, that's not bad. That's a straight line right there. Next thing is I have got to do Ben's one, which I shall do in a light blue color here because Charlie's already there. So Ben starts at 12,000, which is there, and then 6,000, 3,000, now it's getting hard with this thing. I'm gonna try 1,000, 1,500. What else do we have? 750. At 4, it's at 750. No, it's not 750. That's yes, 5 blocks. It's going up in 200s. So at 4, 600, 750 is going to be there. As you guys can see, it is starting to get a little bit tight up here in terms of trying to get these points. 7 is, yeah, no, it's going to be like pretty much tiny there. Sorry guys, like, I mean, that's, but you know, if we're trying to draw this as a curve, it's going to be super tricky, but I'm going to try my best. Really, the key idea is that you don't want that light blue line to be touching it. So you can actually kind of like just make a comment in there that this is an asymptote or whatnot. But yeah, so that's part 2 right there for the graph. And looks like you might get 1 merit value if you have graphs of Anne and Ben. So that's the red and blue graph. If you get it, you get a merit value for it. But if you find the equation and put graphs of Anne and at least 2 non-trivial comments. Jeez. Where's that non-trivial comments? Oh, right, there's more in this question. Okay, let's go back to the question here. So we've got those 3 things that are happening. Now there's 2 extra parts to this question. We've got to find the equations for Anne, Ben, and Charlie. And then we've got to compare each of these points. So I guess we'll do it all together and then we'll go and look at the answer schedule, all right? Just to try and figure out where all these marks are coming from. So the first step is looking at the red equation, which is Anne. So I'm going to find the equation for Anne. So I'm going to choose 2 points for Anne. One is 0, 4,000, and the other one is 8, 0. Okay, and like I said to you guys before, I will do this with the long method. If you have a graphics calculator, you can just put those 2 values, which I might just show you guys graphics calculator first. So go into stat mode, and we've got 0, 4,000, and 8, 0. And let's go graph calc x. So we should actually get Anne's equation as minus 500x plus 4,000. Okay, so let's do this the long method. The long method is this. That value, the 4,000, is your c value or your y-intercept. So we can rewrite this as... So we can write this as y is equal to mx plus 4,000. And then of course gradient is change in y divided by change in x. So 0 take away 4,000 divided by 8 take away 0, and this is going to give me minus 500. So Anne's equation then is equal to y is equal to minus 500. Now you can put x, or you could actually use number of points and time. I guess if you want to use minutes, so you could actually have m and number of points as capital N, but in this case we can just go minus 500x plus 4,000. So now that's Anne's equation. Next we're going to be looking at Ben's equation. Yeah, let's look at Ben's equation. So with Ben's equation, what we've got here is, I'm going to take down those 3 values first, which is 0, 1, 2, right? So 0, 1, 2, we've got 12,000, 6,000, and 3,000. Now, when you think about a kind of like exponential equation, because this is exponential, how do I know? Because it's actually halving or doubling. Remind me tomorrow. So in this case, we can see that the ratio is actually, it's actually halving each time, right? So we can put the ratio as 0.5. Now, in saying that, what we also know is that we could actually write this as ARX plus C. Now, this is the equation that I tend to use for exponentials. Now, if you have something else, that's absolutely fine. Go for it. You could use that. And I am going to show you the longer method here, but trust me, if this method actually works for any exponential equation, so therefore you don't need to worry about it. So what we're going to be doing is we're going to take the 0 and 12,000 first, and we're going to substitute it in here. So we're going to get 12,000 equals A, which we don't know what it is. R in this case is 0.5, and X is equal to 0 plus C. So when we do this, we're going to get 12,000 equals, now 0.5 to the power of 0 is just 1, which means we're going to get A plus C. Now a really kind of good thing to notice is that we are going to use a little bit of simultaneous equations, but that's all right, we'll just use another point. So our second point that we're going to use is 1 and 6,000. So we got y equals ARX plus C, so which means we've got 6,000 equals A. R is 0.5 to the power of 1 plus C. So we're going to get 6,000 equals 0.5 to the power of 1 is just 0.5. So we're going to get 0.5a plus c. Now we've got these two equations and I'm going to stack them on top of each other. So I've got 12,000 equals a plus c. I've got 6,000 equals 0.5a plus c. And I'm going to subtract everything. So 12,000 minus 6,000, a minus 0.5a, and c minus c. When I do this, I'm going to get 6,000 equals 0.5a, c minus c is 0, and then I can say that a is equal to 6,000 divided by 0.5, so a is equal to 12,000. Now if a is equal to 12,000, because we have a plus c equals 12,000, and if 12,000 is what a is, then we can say that c is equal to 0. So our equation for Ben then is going to be y is equal to 12,000, 0.5x. So this is for Ben's equation. Now I know it seems like a lot of work here for this particular equation, and you know, the more you do, the more you kind of realize that you could have done this without the simultaneous equations. But again, like I said to you, like these kind of questions, like you get better at it as you start practicing more. All right, so the last question that we have here is not last question, last equation is the quadratic equation. And we've actually got 2 points for the quadratic, right? Now our first point for the quadratic is 0, 12, 2, 50. And our next point that we're going to be using is 7 and 0. So with using the graphics calculator, you're going to need one more point. And I guess what you can do is you can actually treat like this quadratic equation, you can kind of like make it go around like this, which means this point here is going to be negative 7, 0, like using symmetry. And you'd use negative 7, 0, and then use those 3 points in the calculator to work out what the equation is. So that's what I'm going to do here. I'm going to quickly go in here. Let's see, we've got 0 and 12,250. That's going to be 7. There we go. We're going to graph it, and we've got x squared. And as you can see, that is what my equation is for the quadratic. So for the quadratic, I go y is equal to negative 250 x squared. There's 0x because b's value is 0, plus 12,250. So that is how you do this on the calculator. Now if you want to do this without the calculator, you've got to kind of understand that there's 3 ways of writing quadratic equation, and this particular one, all we have got here is y is equal to ax squared plus c, because this parabola is just moving up or down. And we know what the c value is because that's 12, same thing as what we did with the straight line equation. So we're going to get ax squared plus 12,250. Now we need to figure out what the a value is, and to do that we're going to substitute a point, and we're going to choose 7, 0. So when we choose 7, 0, what's going to happen is we're going to get 0 equals a times 7 squared plus 12,250. Rearrange this. We're going to get minus 12,250 is equal to a. 7 squared is 49. And then a is equal to negative 12,250 divided by 49. And I'm hoping that we get negative 250. So here we're getting a is equal to negative 250. So we can rewrite this as y is equal to negative 250 x squared plus 12,250. So those are your 3 equations for Anne, Ben, and Charlie. So there we go. I've got all of my 3 equations there. Now I think if you find all the equations, just kind of go back to this. no, I think I'm going to, no, you still, if you find one of those equations, it's an or, so you could get merit for finding one of those equations, which is actually pretty okay. So I guess if you find one of those equations, like finding Ben's equation, you could get a merit for it. And Ben's equation is an exponential one, and Charlie's is an exponential quadratic. So yeah, it's not bad for one merit, but for two merits, which is the 2R, graphs of Ann and Ben. Oh, I still need to give some comments. All right, so that's part 4 of this question. So let's go have a look at it now. Where are we at? So part 4 of this question is, it is a bit trivial, right? Like, I mean, you're comparing each player's points over the course of this game, including who will play the game for the longest time and so on. Now, guys, like, the thing I'm going to say is, like, you know, there's just so many things that are happening within the graph. And I guess what you guys will need to do is you actually need to write about this in your own words. Now, one thing that I would say is, like, let's have a look at some of the things that are happening here. The first person to lose the game is, or like finishes first. Charlie is the one that finishes first because, like, after 7 minutes, he is pretty much done. The one that's going to be playing the longest is Ben, because he can play up to like 9 minutes. We can also make a comment like about that point where these two are meeting. So around the 2-minute mark, Ann and Ben, yep, Ann and Ben have both the same number of points, which is around 3,000. And then you can also talk about this intersection here, which is Ann and Charlie. They have about, what would it be, Ann and Charlie at 7th minute. Oh no, not that one. Oh no, it's gone. Oh, where did it go? So we've got Ann and Charlie who are around here. Have I made a mistake? Ann and Charlie around, no, not really. I mean, like, it's around here, right? You can kind of see it's around the 600 mark. So you can actually say Ann and Charlie have around 600 points roughly. And so if you think about it, I'm just coming up with like all these different situations that could potentially happen. And one of the things I did say in the question was like, who will play the game the longest, which we kind of mentioned. Also, we can see that Charlie has been in the lead the longest as well, because his graph is always at the top. You could also say that after that 6.85 minutes, Charlie loses the lead and comes in the lead, and then after that 8-minute mark, it's whoever blew Ben is actually in the lead. So I'll show you guys some of the statements they've actually put in. So kind of similar kind of comments there. So it's kind of open to interpretation, how you interpret it. But my recommendation is you try and write like about 3 to 4 comments. I would say 4 comments is probably quite useful, because if you look at the answer schedule itself, they are actually saying like for an excellence, which is like to get like the full 2 excellence grades, you need at least 2 non-trivial comments, right? And that Ben plays the longest. So you need all 3 equations, evidence of the table, you need the graph, and you need the comments to get an excellence. And like I said, this is one of those weird questions where it's just like this one massive question and you're getting a lot of grades falling out from different aspects of it. But pretty much, guys, that is question 1 for us, and we go to the next question. All right, so we go to the next question, guys. Next question, what we've got here is sketch the graph of 2x plus 2. All right, so what I'm going to do is I'm going to make a quick little table here, and I'm going to list down all my x values that I have, which is -2, -1, 0, 1, 2, 3, and 4. And I've got 2x plus 2, so this is going to become 2 to the power of 0, 2 to the power of 1, 2 squared, 2 cubed, 2 to the power of 4, 2 5, and 2 6. So in other words, I've got 1, 2, 4, 8, 16, 32, and 64. So all I'm going to do is I'm going to kind of put these points on this curve and then just curve it out. So at -2, I've got it at 1. At -1, it's at 2. At 0, it's at 4. At 1, it's at 8. At 2, it's 16, 32, and 64. Okay, try and get a nice smooth single curve. Trying my best here. And what I will also do in this case, you could put like a little arrow in there if you want to, but to be honest, you pretty much covered all of it. So this question here is actually worth straightforward achieved, and that's it. We go to the next question. Okay, so the next question, what we've got here is obviously we've got a nice parabola there, and x minus 1 and x minus 4. How far below ground level is the deepest point of the hole? So now the thing about this question is that like they've given you guys the nice graph with the x-intercepts. So what do I mean by that? So think about it like this, right? So notice how you got x minus 1 and x minus 4. Basically you go x minus 1 equals to 0, which is going to give you x equals to 1, and x minus 4 equals to 0, which means x is going to equal positive 4. So this point right here is 1, and this point right here is 4. So if you want to find the depth of the hole, so imagine it like this. Right now, this parabola here, it's looking like this. So what we want to know is the depth at what is the x value in this point. So the x value is halfway between 1 and 4. So we add it up. 1 plus 4 is 5 divided by 2, 2.5. So we've got 2.5. So we're going to substitute 2.5 wherever x is. So 2.5 minus 1, 2.5 minus 4, and we're going to get 0.8 times 1.5 times negative 1.5. And we're going to go into the calculator. 0.8 multiplied by 1.5 multiplied by negative 1.5. It gives me negative 1.8. All right, so that means how far below ground level is the deepest point of the hole? It is 1.8 meters below ground level. So this question here is worth and achieved. And again, this is just you understanding how the parabola is actually working, all right? And the key thing is having a look at the equation and your diagram that's been actually given, and you kind of just work from there. All right, so the second part of this question is we've actually got two ways in which the original equation could be altered to make a safer hole. .8 meters is pretty. Alright guys, so for the second part of this question, we've actually asked for two ways in which the original equation could be altered to make a safer hole. So we're looking at changing the height of the hole, right? So what I'm going to do is I'm going to show this to you in with Desmos, just so that you can kind of get an idea. So what I've done here is I've put in the original equation, which is the black one. That's the original equation, right? Now, the first thing that we could do is we could actually adjust the a value, which is the 0.8 here. Now, the black is the original one, and when I change this, you're going to see the red graph popping up. And of course, we've got our height right now, which is 1.8 meters. So that's the height right there, and we're trying to reduce that height. So if I change the a value, if I make it bigger than 0.8, that hole is actually going to get much deeper. But if I actually reduce it if I bring it below 0.8, then it's going to get flatter. But I think as long as the value is between 0. That's very deep hole there, but like let's go 0.1. So I would almost say, like, if your A value is between 0 and less than 0.8, then that height of that the depth of the hole is actually going to be a lot shorter. So let me just show you guys here, just to give you guys a good indication of it. So when it's actually between 0 and 0.8, you can kind of see what's happening there. The depth of the hole right now is between 0 and 0.8. So that actually allows the hole to actually reduce the depth of the hole. All right, so that's the A values. That's the first point that we can talk about. Our next thing that we could actually do is reduce these points here, which is P and Q. Right now I've put this right here as 1, so that's your P value. And I've put in 4 here, which is your Q value. So if I reduce the distance between that, then you're also going to get the depth of that hole is actually going to get smaller as well. So in other words, I can say that if I reduce the distance between the 2 points, like the 2 x-intercepts, then the depth actually decreases as well overall. So for example, if I say I want it between 1 and less than, I'm going to put it 3.9 so you guys can actually have a look at it. So here we go. As you guys can see, as I'm getting closer and closer, the depth of that hole is is getting smaller and smaller. So that's the second point that you could actually talk about. Now the last point that you can talk about is this right here. You could actually add an R value at the end of the equation, because you could literally add, when you lift it, any value above less than 1.8, the hole is actually going to be lifted up completely. So in other words, if I show you is between 0 and 1.8, oh, hang on, where did it go? 0 and 1.8. Let me just figure out what happened here. No, it seems to be doing that. There we go. So you can kind of see it, like if it's less than 1.8, the depth of that hole is going to be a lot less as well. So 3 points that we can talk about here. The first is changing the A value. Second is moving the gaps closer. And third is moving the entire graph up to the top there. And if you look at it, those are the 3 points that they talk about. One of them correct is going to get you an achieved. 2 valid comments is going to get you a merit. So my magic number is, like, 3 to 4 is always good for these types of questions. Okay, so let's get rid of that. Yeah, we'll leave. We're going to go back to the main recording there. So that hopefully that kind of helps you guys visualize what's happening with part 2 of this question. All right, so moving on to part 3. Part 3, we've got to write the equation of this model. So again, this is just an exponential equation. You can look at it exponential because if you look at the values, they are all getting halved. So straight away, we can say that the ratio is going to be half, or 0.5. I'm going to put it as 0.5. And then we just need to figure out what the equation is. So I'm going to put down y equals ARX plus C. Now, if you are confident, you might just see this graph straight away and go, oh, it's just 0.5x. And if you can see that, that's great. And if you can't see it, you might need to do simultaneous equations. So we're going to substitute the values. So we've got 1 equals A, 0.5 to the power of 0 plus C. So we're going to get 1 equals A plus C. Then I'm going to repeat that with the second point with 1 and 0.5. So I'm going to get 0.5 equals A times 0.5 to the power of 1 plus C. So I'm going to get 0.5 equals 0.5a plus c. So put these two equations on top of each other. 1 equals a plus c, 0.5 equals 0.5a plus c, and I'm going to subtract each one of those elements. 1 take away 0.5 is 0.5, a minus 0.5a is 0.5a, c minus c is 0, so we can see that a equals to 1, and because we got this equation 1 equals a plus c, 1 equals 1 plus c, we can say that c is equal to 0. So our equation is y is equal to 0.5x. So the grade for this question is a merit, and if you recognize that the ratio or like some form of y equals to 2 to the power of x, you could get an achieved. So if you have a look here, recognition of the equation as an exponential form could get you an achieved. Alright, so let's go to this last question here. I think this is the last one, is it? 2b4, yes it is for this part of this question. Okay, so for this question here, it's interesting because like in the answer schedule it explicitly says do not allow CAO only, correct answer only. So you've got to show some sort of working here. Now, as I said to you guys before, I am going to do this the long method. I'm not going to do this the graphics calculator method. Fine, I'll do both. But I'm going to do the long method first, all right? Just to kind of show you guys what's happening in this. So the first thing to notice is that the hole's greatest depth. So this line right here is 2.5 at a horizontal distance of 5. So that right there is 2.5. From there to there happens to be 5. So if you think about it as a vertex, this right here is your vertex, which is going to be 5, negative 2.5. And I'm going to write my quadratic equation first, which is y equals to a x minus h squared plus v. Now this is the one that I use, and of course if your teacher uses a different one and you've been using a different one, that's fine. If it works for you, just use that, all right? Don't be like, oh, he's doing it a completely different way or anything. So we've got y equals to a x minus 5 squared minus 2.5. So all I've got here is the 5 is from there, which is the horizontal movement, and the minus 2.5 is your vertical shift right there. Now I've got to figure out what the a value is. To figure out what the a value is, I'm going to use the point 2, 3, this right there, which happens to be 2, negative 1.375. So this is the point I'm going to be using to try and figure out what the a value is. So to do that, I put in my y value, which is negative 1.375 equals a times x, which happens to be 2 minus 5 squared minus 2.5. So I'm going to rearrange this particular equation, and I'm going to try and work it out. So I've got negative 1.375 equals a times negative 3 squared minus 2.5. I take the minus 2.5 to the left hand side, which becomes plus 2.5, and I've got negative 3 squared, which happens to be positive 9. And still kind of working through this, I've got negative 2.5 minus 1.375 is 1.125 equals 9 times a, and then a is equal to 1.125 divided by 9, which gives me 0.125. So my a value is equal to 0.125. So my equation of this parabola is y is equal to 0.125 x minus 5 squared minus 2.5. Now the question itself is asking what is the surface, how wide is the hole at the surface of the water, right? So the thing that I know is, I know that I can figure out what this part right here is. All right, so imagine it like this. At that x value, whatever the x value here, the y value happens to be minus 2. So I need to do that first to try and figure it out. So in other words, I am looking for when y is equal to negative 2, what is the value of x is what I'm looking for. Okay, so once that's done, I'm going to go negative 2 equals 0.125 x minus 5 squared minus 2.5. So I need to rearrange things. I am going to bring the 2.5, which is plus 2.5, equals 0.125 x minus 5 squared. Now negative 2 plus 2.5 is 0.5 equals 0.125 x minus 5 squared. Next, I need to divide by 0.125, which then equals x minus 5 squared. So I've got 0.5 divided by 0.125, which gives me 4. So I've got 4 is equal to x minus 5 squared. Now, what you could do here is you could actually expand this quadratic, rearrange and find your two solutions, or you could actually do this. So you can say x minus 5 squared is equal to 4, then x minus 5 is equal to square root of 4, x minus 5 is equal to plus or minus 2. It's pretty much the same thing as what you would do if you were to expand and rearrange. So you got x minus 5 is equal to 2, x minus 5 equals minus 2. So when we rearrange this, we're going to get 2 plus 5. So x is equal to 7, or x is equal to minus 2 plus 5, which actually gives me x is equal to 3. Now, I've got two answers, and you might be wondering, how is that possible? Well, think about this. It is possible because there is actually 2 points when this water level is going to be at 2 meters high. So the first one, which was the 7, and the second one, which was 3. So if we look at the question is actually asking how wide, I'm going to need a different color here, how wide is the hole at the surface of the water. So we're actually looking for this distance here, which is that distance there, and we can see those two x values are 7 and 3. So we can write a statement, width is 7 minus 3, so width is 4 meters at water level. So bit of a long question, you know, what's expected. That's an excellence question there. But if everything works out correct, then you actually get, it's one of those 2 excellence questions. So you get a T2. Let me just show you guys this. Yeah, so you get an E8 if you say width of the calculator with fully working algebraic or graphical. Now the graphical one I'll show you guys very shortly of how to do this. But minor error, you're looking at an E7. Okay, so with the graphics calculator, I mean the steps are still the same, right? So you still have to figure out what the equation of the graph is. So to figure out the equation of the graph, I'm going to take down 3 points here. So my 3 points, trying to figure out. So for the graphical method, what I'll do is I'll just sketch a rough graph here. So my first point is this one here, which is 5, negative 2.5. My next one here, which happens to be 2 and 1.375. But symmetry wise, I could also say that this point here is going to be 8, 1.375. So those are my 3 points that I need to work out the equation in a graphics calculator. So I've got 2, 5, and 8, 1.375. Oh, that should be minus. Oh, I just realized, sorry. Should be minus 1.375 minus 2.5 minus 1.375. So graph 1, calc, x squared, and there we go. I get my equation, which is y is equal to 0.125 x squared minus 1.25x plus 0.625. So that's the equation. Once I get the equation, I should be able to just draw it. Let me just see if I can copy it. Yes, go menu, graph, and draw. Yeah, see, this is what happens with it. It's alright, I'll just type it up again. 125x squared minus 1.25x minus 0.625. Nope. Plus. Okay, so there's my graph. And then what I can do is I can click on Gsolve and I can click on xcal. So enter the y value, which is -2. And as you guys can see, I get x equals to 3 and x equals to 7. So I actually get my two values when the depth is when the depth is at 2. So it actually gives me my 7 and 3, and then I go 7 take away 3, which gives me 4. So with the graphics calculator, they only accept calculator from certain point onwards, which is kind of weird, because, and I guess that's why they say right at the beginning of this question, do not allow correct answer only, because you can actually, I mean, I just did the whole question in like 2 steps in the graphics calculator. But I guess for you guys, it's a good way to check your answer. But keep in mind that you want to be trying to show some sort of algebraic working as well. So yeah, so as you guys can see, this question, there is lots of things that's happening again, right? Like you could get an achieved just for writing your basic. So as you guys can see, lots of possibilities in terms of grades that you can get. I mean, like you could get an achieved for just putting the quadratic formula in just a vector, like vertex form. You could put, yeah, try not to record during with your son in the house. It's just nothing's doable, so many breaks. But anyway, where were we? Yeah, writing the equation in a vertex form is going to get you an achieved, or if you just put a correct answer only, you can also get an achieved, right? Correct equation of the curve, merit. That's pretty decent merit. Don't worry about the, I mean, I think I hardly see anybody drawing graphs, but if you do can get stuff out of graphs, man, that's pretty cool. But apart from that, that's basically it for this question, guys. Alright guys, so on to question 3. Now again, with this question, graphics calculator, 3 points. What have we got? We've got -1 and 9. We've got 2 and 0. And we've got -4 and 0. So we're going to put this in the graphics calculator now, and I will show you guys the long method of how to do this, so don't worry. We've got new stat mode. Where are we at? Menu, stat mode. So my values are -4, -1, and 2. We've got 0, 9, 0. And so our equation for this graph is y is equal to negative x squared minus 2x minus 8. So how are we going to do this without the graphics calculator? So without the graphics calculator, I'm going to write my vertex form, which is x minus h squared plus v. So the h value is this one right there, which is -1, and the v happens to be +9. So I can rewrite this as a x minus -1 squared plus 9. So I'm going to get y is equal to x plus 1 squared plus 9. So to figure out the a value, I need to substitute 1 point. Could be 2, 0 or -4, 0. Doesn't really matter. I'm going to use 2, 0. So I've got a 2 plus 1 squared plus 9. I've got a 3 squared plus 9. Rearrange. I've got 0 take away 9, which is going to be -9, equals a times 9. Then a equals -9 divided by +9. And so I can see that a is equal to 1. So then my equation is going to be -1, -1 x plus 1 squared plus 9. So you could leave your answer like this, or like this as well. And of course you could also use the vertex method, intercept method as well in this. Yeah, like I said, there's lots of ways to get to the answer for this question. So it is worth achieved. That's part 1 of this question. Okay, so next part of the question. Oh, really? You got to draw a bunch of patterns? Oof. Okay, so with this one, I'm just going to have a look at what the difference is. So here I've got +12, here I've got +18, and I'm guessing it's going to go +24. You can draw the pattern and actually count the points if you want to, but to be honest, you do enough of this, you know what's actually happening. So 36 plus 24 is 60, and then you've got +12 plus 18 plus 24, so +30, which is going to give me 90. And this question, both t values answered correctly, is going to get you an achieved. Find an equation that represents the total number of dots in any given pattern. So, this is interesting, this question. I mean, looking at this question, I know, like, again, putting this in the graphics calculator is going to spit out an answer straight away for me. So what have I got? 1, 2, 3. I don't even need the fourth one. 6, 18, 36 should get me this, but let's have a look. X squared is 4. Yeah, there you go. Like, I mean, that right there is going to get me the correct formula, which is y is equal to 3x squared plus 3x. And looking at the answer schedule, this is worth a merit straight away. Now you can actually do this the long method, which I'm going to try and attempt right now. I guess the first thing I could look at is like what's happening before. So +12, and before this will be like +6. So pattern number 0 is actually going to have 6 minus 6 is actually going to have 0, 0. So I can straight away see that this graph is actually going through the origin, which is 0, 0. Because it's going through the origin, I can actually say that if I was to write like this, y is equal to ax squared plus bx plus c, because it's going through the origin, I can rewrite this as ax squared plus bx plus 0, because that c value is 0. So at this point, I got to figure out what the a value is and figure out what the b value is. Now the a value is, I can look at could look at the second difference, but you could also do this by simultaneous equations. And because I'm obsessed with simultaneous equations, I'm going to try and show you guys that method. All right, so we've got 1 and 6, and we've got 2 and 18. So I can say 6 is equal to a times 1 squared plus b times 1, and then 18 is equal to a times 2 squared plus b times 2. So here I've got 18 equals 4a plus 2b, and then here I've got 6 equals a plus b. You can kind of do rearranging if you want to. So we can say that a is equal to 6 minus b, and then substitute. So let me just do that a little bit slower, sorry guys. So I could rewrite this as a is equal to 6 minus b, and 6 minus b is equal to what a is, so I can substitute it here and figure out what b is. So 18 equals 4 times 6 minus b plus 2b. I've got 18 equals 24, take away 4b plus 2b. 18 equals 24, take away 2b. And I've got 18 minus 24 equals negative 2b, which is going to give me negative 6 equals minus 2b, and b is equal to negative 6 divided by negative 2. So b is equal to positive 3, and if b is equal to positive 3, 6 minus 3 equals a is also equal to 3. So my equation is 3x squared plus 3x. Second difference method is, you can look at the differences for the second difference here, which is, you can kind of see that this is plus 6 plus 6 plus 6. So because of that, a is equal to 6 divided by 2, which means a is equal to 3, and then you can substitute and figure out what b is. So pretty much simultaneous equations takes a long time, obviously, but see, this is, I haven't actually done second difference in a long time, and I guess I kind of just drifted off. But anyway, merit question. Go to part 3 of this question, and I think I might have actually not copied the entire part of this question, by the way. Let me just have a look at it. Yep, looks like I missed the part 3 of this question, guys. Part 3 is use the axis below to draw the graph that represents the relationship between pattern number and number of dots. So all we're really doing is just drawing that graph that from the tables. So we've actually got the table there. At 1 we've got 6, at 0 we've got 0, at 1 we've got 6, so 6, which if this is 10, 6 is probably there. At 2 we've got 18. At 3 we have 36. For 60, 590. And I'll probably keep going, right? Because they've got 6, 7, and 8. So to do this, I would need to actually go into my calculator, and I'm going to substitute those values. So you actually had 3 multiplied by, what do we got? X squared, right? So it's x squared plus 3x. So we're going to put 6 squared plus 3 times 6. So that's 120 at 6. So 120 at 6 is going to be here. Then we've got to do it for 7. So I'm just going to replace all of those things there, which is 161, which is somewhere here. And then we've got 8. Which happens to be 208. All right, so with this particular graph, guys, just having a look here. C. Where is the graph? All right, so with this graph, it's really important to notice that this is a pattern question, right? So that means you can't actually, you shouldn't join this graph at all. You should actually just leave them as dots. So including negative values. So if you were to put a continuous line, like if we draw a line on it, this question becomes an achieved straight away. And if you have correct discrete values only for at least into 5, allow 0, 0 if it's a discrete graph. Yeah. So if you were to do this, then you are going to get a merit for this question, because remember that you can't actually have pattern 1.5 or 2.5 and so on. And if you draw a line, then what you're saying is that you actually have patterns between 1 and 2, which is theoretically not possible in this case. So yeah, just to keep that in mind, always think about the context of the graphs when you are plotting. Anytime you're plotting a graph, you got to think about the context. Can you have something in the middle? Is it possible for it to have something in the middle? And if it doesn't work, then leave it as a discrete. Discrete means like single points, right? Like continuous is like it's like in between there's things happening. Like your height, for example, is continuous, but the number of fingers you have is theoretically discrete. Well, it's probably the worst example to use, but anyway, let's go to the next question here. All right, guys, so for the last part of this last question is, again, we've got one of these big questions with lots of things that's actually happening in it. And I guess what we're asked to find is investigate the relationship, lengths of the two parts, and the area. So first thing to kind of realize is that we're only using the fence is being put in the edge, right? Like what do we call it? The planter box? Yeah, the planter box is being put at the edge. So if I was to write down two things, I'm going to write down height. Oh no, I'm going to call it width and length. All right. So from here, my first statement is width plus length is equal to 60. All right. That's the first thing. Now the question's actually asking us to investigate the relationship between the length of the two parts and the area. So we need to work out what the area is. So area is length times width. But we know that length is actually 60. Take away the width. So we can rewrite this as area is equal to length times length minus, no, 60. What am I doing here? I want to replace length, right? 60 minus W multiplied by W. So that is pretty much the equation. Now from here, what we can do is we can kind of start looking at it. I mean, you can make a table for this. They do say use tables, equations, and graphs to investigate. So you have to actually use all three, which kind of sucks, but like, to be honest, just having a look, give me one. So table produce of the relationship between two lengths of wood and their area. So they're looking for minimum 2, I guess. That's, yeah. So I would actually put down like this, right? So for example, length, width, and area. So if I have the length is 60, then the width is going to be 0. I'm just going to make it like a little table here. Then the area is going to be 60 times 0, which is just 0. Now if I have 55 as the length and width as 5, then I'm going to get 55 times 5, which is my area, which is 275. I probably would just, you know, just in this case, I probably would go up in 5s. So I would do 50 and 10, which happens to be 500. Then I've got 45 and 15, which is 675. Then I've got 40 and 20, which is 800. I've got 35 and 25, which is 875. 30 and 30, which is 900. And I can just keep going like that, right, for my table. Ideally, what you wanting to do is like, I don't know, I mean, like when I look at the answer schedule, they're going up in like 4s. I've gone up in 5s. I don't know why they decided to go up in 4s, but you know, I don't think it really matters, because all you're trying to do is like just show them what this table actually looks like. Eventually what's going to happen is that this whole table is going to kind of come back, because you're going to get 2535, which is 875. Then you're going to get 2040, which is 800. 1545, which is 675. 1050, 500. 5 and 55, 275. 0, 60, 0. So there's my table. I've got my equation at the top there, and I can draw a rough graph. And the graph is a parabola, because if you were to plot all these things, and if I put this like width, for example, so the width is between 0 and 60, and when the width is at 30, the maximum is at 900. So my graph is a parabola shape that looks like this. Now you guys are given a grid. I believe you're given a grid. Yes, you are given a grid, because in there you're actually given a grid with 0. Nice grid for you guys to kind of work out. So put your x values, put your y values, and remember, you can actually get the points from the table and plot it along and then join it. Now I've just done it real quickly here just to give you a bit of an idea of how to do it, but you can actually go in there and take all these individual points and then kind of like plot them all here and try and work it out. So those are my tables, equations, and graphs. So I've done all 3, and then I've got to write down 3 comments. So my first comment could be that maximum area. That's a really good one that always seems to pop up. So I could say maximum area is 900 when both lengths are 30. The graph is symmetrical. Like, let's have a look what these guys have actually said in the. So what have we got? Minimum area is 0. Well, we know that, because if we actually choose one side to be 60, then minimum area is going to be 0. Rate of increase, area changes with different x values. Yep, it's pretty common. This is a continuous one, so you could have like 25.25 as the width. Unlike the previous question, if you remember, there was discrete. You can only have it in like going up in 1s. They also talk about some of the realistic x values. Like, you can't really have a planter box that is 59 centimeters that way. Is it 59 centimeters? Yeah, 59 centimeters that way, and then have like a height of 1 centimeter. There's going to be nothing that's going to be planted that's going to grow out of that. So it's just kind of like being a bit realistic about some of your comments. And looks like you need at least 3 valid comments. All right. So my thing is like, whenever you're doing the area questions, do the maximum area, do the minimum area. Most of the time your graphs tend to be symmetrical. So that's something that's always that you can put in mind. And then think about it, and realistically, how possible is some of these values. So once again, it's one of these types of questions where there is a lot of marks that are coming from all over the place. Like, for example, if you just do table, finding maximum area only is going to get you an achieved. Table and graph drawn, no comments, gets you an achieved. So even though, like, when you guys are doing this in the exam and you're looking at an investigation question and you're like, oh, I don't know what to do, draw a table, get some rough values, put it together, and then once you get a table, put that table into a graph format, and you can get a nice achieved. But if you have a look at the actual thing here, like where we put tables, equations, and graphs, no comments gets you a merit. So for an excellence, you need table, you need the graph, you need the formula, and only maximum area discussed. So you don't actually make any other comments. You could still get an excellence grade for it. But for a double excellence, you're looking at 3 big comments there. So I guess to wrap this up, let's have a look. Yeah, so wrapping this up, I mean, some really quite straightforward questions, but also some kind of like out there long questions for excellence. In terms of the use of graphics calculator, guys, like I've always said, you know, having it is, there is a slight bit of advantage, but the way it looks like from looking at last year's paper, the way they ask the questions, it's like they wanting you to do the algebraic work behind it. So get used to doing things without the graphics calculator, but use the graphics calculator as a guide to check whether your answers are correct or wrong. Anyway, I do apologize about the length of this video because I know we've had a lot of things to cover. But yeah, like don't ever leave any questions empty, especially in tables, equations, and graphs, because you'd be surprised at what you can get for an achieved or a merit. So excuse me. So make sure you attempt every question, and just want to wish you guys good luck for your exams, and yeah, there should be something popping up.
Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.